So example 4, I'm going to catch up with y'all. Load my calculator. Calculator. There you go. Calculator. It's going to take some retraining of my brain to say calculator, but I think that's a change that I'm going to make for life. Thank you, Aiden. I like it. I like it. All right. So it says if f of x is arcsine of x, using a calculator, evaluate the following to 3 decimal places in radians, right? In radians. So what the heck does arcsine mean? Arcsine. Inverse sine, right? It's another name for inverse sine. Your calculator uses inverse sine, which is second sine, sine to the negative first. But I like to use arcsine because there's no confusing with the reciprocal. So if I say f of 0.82, of course, you could write that out. You could plug it in and call that arcsine of 0.82. Would 0.82 represent an angle or a ratio? A wrangle or an atio? Arcsine of 0.82. It's a ratio, right? It's a ratio. Okay, because remember, we take trig function, sine of theta, an angle, cosine of theta, an angle, to find the ratio. We take inverse trig or arc trig of ratios to find angles. And we're talking about the function f of x, so there can be only one output. So before we go to the calculator, tell me in which quadrant will this angle live? Remember what the PVR for sine is, or arcsine? It's the half moon, right? Half moon. So if you have a positive ratio, you're going to get a positive acute angle. And if you have a negative ratio, you're going to get a negative acute angle. 0.82 is a positive ratio, right? So we should get a positive acute angle. So I should get an angle that's between 0 and pi halves, which is about 1.57. So I should get a decimal between 0 and 1.57. All right. Your default is radians. So if you were in degree yesterday on your own, make sure you switch to radians. But here I go. Second sine of 0.87, close parentheses, boom. And we get 1.055 radians. I'll put rads behind it just so I really. Pooper scooper. I was close. Oh, there we go. Okay. 0.961. Thank you. 0.961 radians, not quite a full radian. Is that a positive acute angle? Yeah, it is. It's not quite one length of the radius around the circumference. All right, so that's good. All right, letter B, f of -1/3. That's the same thing as arcsine of -1/3. What type of answer should this give us? An angle in quadrant what? An angle in quadrant 4. But are we going to go all the way around to get it? No, right? We're going to go straight down. So we're going to get a negative acute angle. Let's try it out. Arcsine or inverse sine of, don't tell me, -1 divided by 3. Look, I did it this time. Negative, thank you, 0.339, right? Or if you rounded, you would put what, 40. You would need the 40. You need the 0 at the end. All right. 3/2. What type of answer should we get on this one? Yeah, D and E. Because remember, if this is a ratio, what are the legal ratios for sine and cosine for that matter? They have to be between what two numbers? -1 and 1. -1 and 1. Is 3/2 between -1 and 1? No. So I should get D and E. I'm not even going to do it on my calculator. If you did it on your calculator, you would get error. Calculator. Error domain. Calculator. Error domain. It's not in the, it's so you don't put error, Brady, right? You put D and E, right? Yeah. Okay. There's no such angle. Does not exist. Calculator. Okay. So that was fun. All right. Look at this. Sometimes if we don't define it as the function right here, like f of x equals, sometimes if we have an expression and we want it to be the inverse sine function to denote the difference between the operation, which has infinitely many different answers in a given interval, versus the function that has only the one in the PVR, principal value range, we use a capital letter, okay? So that's what the capital letter means. One output, the function. So let's look at this right here. It says find the exact value of the following. Cosine of inverse sine of 3/5. This is composition, right? That's not multiplication. So if you're going to do the sequence here, you would take the inverse sine of 3/5, which would give you an angle in quadrant what? 1, right? And then I want to turn around and take the cosine ratio of that same angle. Boom. Can we do this without a calculator? Maybe, right? Is it the angle that I'm after, like on the previous problem? Is the angle my end result? No. I want to find the angle whose sine is 3/5, but then I want to take the cosine ratio of that same angle. So my output is going to be a ratio. So if you want to just type it in, watch this. We can just type it in, cosine of inverse sine. Your calculator always assumes it's the function of 3 divided by 5, close, close. You could get a 0.8, right? That's kind of a boring answer, though. That's not that fun. That's just me testing you. Can you type keys like a monkey? Yeah, you could just put it on. How about just do the switcheroony? Take your iPad and your phone, and then put the test where that was. There you go. Look at that. Like Indiana Jones from Raiders of the Lost Ark, right? And hope a booby trap doesn't come. Yeah. Do you need a note? Okay, here. Will you write your own note and I'll sign it? Okay. All right. Write your own note and I will sign it. I will sign it. Oh, now you could say, please deposit $52 million into the account of Emily Karanko. Mr. Corpy said, right? Yeah, the pen goes back over here, Emily, when you're done. It goes back into this Yale. It says Yale University Educator Recognition Award for Outstanding Dedication to Students. That's where it goes back in there. Yale. Right. Is that even a good college? Yale?
Like saying yell with an accent.
Right, that's right.
Yale.
He didn't hear me, so I yelled at him. Mama.
It's International Moment of Laughter Day.
Oh, there you go. All right. Hey, look, we could do this without the calculator. Let me show you why. This is like a concise 2 clues problem, okay? Where you provide one of the clues. I'm giving you a ratio and we're ending up with the ratio. So let's go ahead and draw a picture. Draw a picture. Not any old picture. Let's draw like a relevant picture. Inverse sine of 3/5. Now, normally on a 2 clues problem, we would say sine is positive in quadrants 1 and 2. And then we would need another clue to narrow it down to one of those 2 quadrants. But in this case, we know it's got to be in quadrant 1, right? Because that's in the PVR. So I'll draw a generic terminal ray. Here's theta. I'll drop a perp. Boom. Now I can label 2 of the 3 sides because sine is y over r. Oh, yeah, thanks. So here is 3. Here is 5. Now, if I know 2 sides of a right triangle, can't I find the third?
Yes.
I sure can by the P theorem, right? The P theorem says when you got to go, you got to go. Right? Yeah, a squared plus b squared equals c squared. So 3 squared plus x squared equals 5 squared, and we get 4. Do your math homework. That's your old 3, 4, 5 right triangle. That's a Pythagorean triple. So if you didn't recognize that as a 3, 4, 5, 1, 2, 3 is not a Pythagorean triple, but yeah, right? Yeah, good. Yeah. So anyway, it's 4. Now that we know all 3 sides, we don't need theta because what do we want to have? The cosine ratio. And what's cosine? X over R. So the answer is 4/5. Hey, and what's the decimal equivalent of 4/5? 0.8. So the calculator is as smart as we.
We are as smart as calculators.
No, the calculator is as smart as we. Not we're not as smart as the calculator. We're the calculator. We put the pressure on the calculator. Yeah, the calculator. All right. Yeah, calculator. All right.
Is this smart as a game console?
Yeah, yeah, yeah. All right. Do this one without a calculator on your own and verify it using the calculator. On your mark and set, go. I'm going to take attendance. All right, tangent of arc sine of 3/5. Well, here's the easy way to do it that anybody could do, right? Tangent of arc, which is inverse sine of 3 divided by 5, close, boom, 0.75, which of course is 3/4, right? But that's not how we're going to do it, because if I gave you this question on the next test, it would be without a calculator. Oh me, oh my. So let's see. If I take the arc sine of 3/5, it's going to give me an angle theta in which quadrant? Quadrant 1, right? Not quadrant 2, quadrant 1. And then I want the tangent of that angle. So I'm starting with the ratio. I'm going to end with the ratio. Let's draw ourselves a little picture over here. Quadrant 1, right? Because it's a positive ratio. 3/5. So here's 3, 5. So is this your old 3, 4, 5 right triangle? Again? Again. Wow. Again. But now I want the tangent, right? Which is what? Y over X. So that's 3/4. Kaboom, kaboom. Shaboom, shaboom. Shaboom, shaboom. All right. And then how about this one? The cosecant of the inverse sine of 3/5. Could you do this one without even drawing a triangular triangle? Yeah, I want to find the cosecant ratio of the angle whose sine is 3/5. How are cosecant and sine related? Reciprocal. So if the sine ratio of that angle is 3/5, what's the cosecant ratio of that angle? 5/3. Thirds. Yeah. And of course, you could verify that on the calculator. All right. Here's the last thing we're going to do today, right? Example 6. You ready? Example 6.
I think I got it down. I had to like draw the chart on the side.
Righty. If we are going to put the decimal equivalent of 5/3, it's not 1.66. Everybody tell them what it is. It's 1.666. Don't be afraid of the beast. Okay. 3 decimals.
Got it.
Okay. Yeah. Hey, if 666 is the number of the beast, what is 667? The neighbor of the beast. Number of the beast, neighbor of the beast. Okay. All right. Devil joke. All right. Here's some properties of sine and inverse sine. Remember, any two functions, when you compose them back to back, they undo each other. But there's a little caveat to sine and inverse sine, because remember, we restricted the domain of sine. So arc sine has a principal value range. If we are taking the sine of arc sine of x, they will undo each other to just give you x if your starting value of x, which is what? An angle or a ratio? This is a ratio, right? If your starting ratio is a legal ratio, then it'll undo itself, right? What are the legal ratios for sine? Anything between -1 and 1 inclusive. But if it's an illegal ratio, if it's outside of 1, like 3/2, then of course the answer is what? D and E, right? Yeah, D and E. So it'll always undo itself if you start with the legal ratio and you just take the sine of arc sine. But
Mr. Corby, I have a math joke for you. Your 666 comment made me realize I had this in my photos. If the number 666 is considered evil, then 25.8069758 is the root of all evil.
or the root of one particular type of evil. All right. Now, if you have the arc sine of x, and you're starting with this type of x, which, because it follows a regular old sine, is a what? Angle. it's not always going to just give you X, not always. Why? Because the angle that we have to end up with when we take the arc sine of that ratio, because this is going to give us a ratio, it has to be in the PVR, right? It has to be in the PVR. So if your X is already in the PVR, then it's going to be that angle. But we can have other angles that are not in the PVR that have the exact same sine ratio. So you got to be careful when you're starting with an angle. You're doing arc sine of an angle. It's not just the angle every time unless it's in the PVR. But there is a way to find it. Okay. Let's come down here and try example 6 and we'll be done for the day. What is sine of inverse sine of negative 0.0316? Well, first and foremost, realize we're taking the sine of the inverse sine. Those are inverses of each other. Normally, we would always just say, hey, 2 steps to the left, 2 steps to the right. We're back where we started. But little caveat here. First of all, is this an angle or a ratio? It's a ratio because it follows the inverse sign. Now, is it a legal ratio? Is it between -1 and 1? Yes. Then the answers, the operations will undo themselves, right? So it will just be negative 0.0316. Done. Don't have to even test it on the calculator. All right. If you want, calculator, if you want to, you can. All right. Inverse sine of pi fourths. Oh, now we're doing inverse sine of sine again. Those might undo each other, but now we're starting with an angle. Is that angle in the PVR between negative pi halves and positive pi halves? It is. So will they just undo each other here? Yes, they will. They certainly will. Okay. It's an angle in the PVR. So it will. So when you do those two right there, someone might get the wrong impression that they're always going to undo each other regardless of the order, right? 2 steps left, then 2 steps right, or 2 steps right, then 2 steps left. Either way, you're back where you started with X. Well, not necessarily true with sine and inverse sine. Let's try this fella. Arc sine of 3 pi fourths. Again, we have an angle. Is 3 pi fourths in the PVR? No. So this is not just 3 pi fourths, but we could figure it out. When in doubt, work it out from the inside out. That's what my grandpappy always said. So let's just figure it out. 3 pi fourths is in which quadrant? It's in quadrant 2. Okay. In quadrant 2, sine is what? Positive or negative? Positive. All I got to do is find the other quadrant where sine is positive that happens to be in the PVR. What quadrant is that? Quadrant 1, right? Quadrant 1. Yeah, it's that easy. If the angle is not in the PVR, you're always going to have, remember, 2 quadrants where the sign, SIGN, is the same sign. Okay? So remember that the reference angles are going to be the same. So what is the angle in quadrant 1 that has the same pi fourths reference angle? Pi fourths. Yeah. So there it is. So arc sine of 3 pi fourths is not 3 pi fourths. It's pi fourths. Now, again, if you wanted to work it out from the inside out, like my grandpappy used to say, you could say, okay, what is sine of 3 pi fourths? It's positive square root of 2 over 2. Now, what is arc sine of square root of 2 over 2? Well, it's either pi fourths or 3 pi fourths, because that's where sine is square root of 2 over 2, but it can't be 3 pi fourths because that's in the wrong quadrant, so it's got to be right. So when in doubt, work it out from the inside out. All right, so it is pi fourths. All right, letter D, arc sine of 13 pi tenths. We're starting with an angle. Yeah. That's over here in quadrant 3. Very good. Is quadrant 3 in the PVR of arc sine? No. So 13 pi tenths is not a unit circle angle, so we don't even know what sine of 13 pi tenths is. So we can work it out from the inside out, but we could do this. In this quadrant where 13 pi tenths terminates, is sine positive or negative? Negative. What is the other quadrant then in the PVR where sine is negative? Quadrant 4. So we want to get into quadrant 4. Now, to get to the same reference angle in quadrant 4, we're not going to go all the way around, are we? Just listen to Drake if you don't listen to me. We want to go straight down to it. So if I could figure out the reference angle, I know my answer will be negative reference angle. Yes? So what is the reference angle?
I'd say 3.
If this is 10 pi tenths, which is pi, and this is 13 pi tenths, how far did I go? It's 3 pi tenths. The reference angle is 3 pi tenths. So this answer is negative 3 pi tenths. Yeah. That's why, if you remember back in the day, I said when you're trying to find the angle, if you always use inverse sine or inverse tangent, as we'll learn, you're either going to get a positive angle that is the reference angle or a negative angle that will be the negative reference angle, right? It's always safer to use inverse sine or inverse tangent because both of those, as we'll learn about tangent, always give you an acute angle, either positive or negative. So if you're looking for the reference angle, if it's positive, you got it. If it's negative, break the negative off, okay?
Use DNE.
Whoa, hang on there, cowboy. Sine of inverse sine of 4 thirds. Ah, they undo each other, right? Yeah, because we're starting with the ratio, I don't need to worry if the angle is in the PVR, right? No, I don't have to worry if the angle's in the PVR, but I do have to worry if it's a legal ratio. Because any legal ratio will always undo itself, but is this legal ratio, Brady? Not at all. It's greater than 1. So yes, the answer is D and E. All right. And we're done for the day. We're going to learn about inverse cosine on Tuesday. Oh, 4 days on, 4 days off. Would you look at the time? Yeah, there you go. Okay. Any comments or questions?
And again, I've had 4 weeks.
Besides Brady?
4 days.
Yeah, Brady. We'll talk about that afterwards. All right. See y'all at fun night tonight.